Okay. Hey, all right. So on example 4, we have it's asking you to talk about find the x values where the function is discontinuous and describe the type infinite or removable. Justify your answer using the definition of continuity, which is the three. Okay. So here's the thing. So if any of those go wrong, if any of them go wrong, you're good to go to say that it's not continuous. Okay, so on this particular one, acting like I do not have a graphing calculator, we know something is going on at 3. All right, x equals 3. So 1, 2, 3. Well, what's happening here is we have an asymptote, and you can think of it as just like before. We've kind of done this on a couple other things. If you didn't have a calculator, so there's the asymptote. As I approach 3 from the right with very very small numbers, it's going to go to infinity. Oh boy. All right. And then as I approach from the left, like 2.9999, that'd be negative when you subtract. And it'll go like that. All right. Now, it does say you can, oh, no, without. Okay. So we're doing without. All right. So what's happening then is this limit doesn't exist. All right. So when x equals 3, that's what I want to write. I think I'm going to type it. I'm going to type it. When x equals 3, the function has a non-removable discontinuity in the form of an asymptote. 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 Okay. And then also, okay, and so since that's the case, therefore, function does not exist at x equals 3. Is therefore discontinuous. Okay. Something along those lines. All right, that would work out pretty nice. Okay, now non-removable. Something is wrong with that. Remove. Look at that. Non-removable. Doesn't like that, does it? Oh, hyphenated. Okay, cool. Okay, now on the second one, then, well, let's try to factor and see what's happening. Okay, we know something's happening at -2, but is it going to be removable or non-removable? We need to find out. All right, so in factoring the numerator, you can, of course, do any factoring technique that you can remember, and that is fine. But just kind of knowing that we have to have that really helps me along, because and we need to set a 7 in the middle, and so the only way to really get that to work out would be a 2 here and a 3 here. And that'll do it. And I should have known we're going to have an x plus 2, but pretend like we didn't know that. Okay, cool. So with that happening, then we know that that's going to happen. So we're going to have a hole or a removable discontinuity, and so g of -2 does not exist. Okay, so let's say escape there, type here. When x equals -2, there exists a removable discontinuity, not in the form of a hole. All right. Therefore, f of -2 does not exist at x equals -2 and is therefore, and the function is discontinuous at that x value. Something along those lines. So, okay. So I think we said what we wanted to say. They said describe the type as an infinite or removable. So we said removable, and over here I said non-removable. That's the same thing as the infinite ones with the asymptotes. And then with our definition of continuity, because the function doesn't exist, that's the 3 steps. So if any part of your 3 steps falls apart, the continuity falls apart.